The thundering roar of Nazi V-2 rockets that once brought destruction now echoes in the silence of abandoned factories and forgotten parts. The war is over, but the remnants of this technological terror still linger, strewn across Europe. Thousands of parts, engines, fuel tanks, and guidance systems, once symbols of power, are left to rust in the wake of a shattered empire. As nations rebuild, these relics, once the pride of Nazi Germany, now become burdens, their legacy slipping into obscurity. The vast scale of this war machine's destruction is no longer a threat. Instead, it is a memory, decaying, waiting to be repurposed or forgotten. The crumbling remnants of a war long over. The powerful thrum of Nazi V-2 rockets that once shook the earth now replaced by a silence that stretches across abandoned sites, rusting machinery, and shifting geopolitical landscapes. What happened to the thousands of components, the pieces of history that fueled the ambition of a regime defeated in 1945? The world had not seen a weapon like the V-2 before, capable of launching destruction miles away with terrifying precision. Yet, as the war ended, the machinery of war itself was left in pieces, and its future, once destined to fuel further conflict, was now caught in the uncertainty of a new world order. The Nazi V-2 rocket program was one of the most ambitious, costly, and scientifically advanced projects of the war. During its development, the Third Reich poured vast resources into creating a weapon capable of changing the course of the war. But when Germany finally surrendered, the focus shifted swiftly away from destruction to rebuilding, repurposing, and, in many cases, eliminating what was once an instrument of terror. The fate of the V-2's pieces, be it engines, fuel tanks, guidance systems, or the launch pads, was now a question of economic necessity, military priorities, and post-war agreements. Across Germany, entire facilities dedicated to the production of V-2 rockets fell silent. The production lines at the Peenemünde Army Research Center, once humming with activity, ground to a halt. Yet, as these sites emptied, another force moved in, the Allies. Within weeks of the war's end, both American and Soviet forces were on the move, securing scientific knowledge, technology, and any remaining materials they could salvage. The V-2 rocket, a symbol of Nazi technological supremacy, had now become a prize to be claimed by the victors, and the disposition of its parts began to take shape in ways that no one could have predicted. The United States, in particular, was determined to harness any potential advantage the V-2 program could offer. The U.S. Army was quick to seize the most advanced models and transport them across the Atlantic. These rockets would not be dismantled, destroyed, or abandoned. Instead, they were carefully studied and reverse-engineered in an effort to jumpstart America's own rocket program, a task that had far-reaching consequences for the Cold War and the space race. But in Germany, as the Allies surged forward, there were other concerns to address. Concerns about the large stockpiles of unused rocket parts, unfinished components, and the tens of thousands of workers who had once toiled on their production. The task of sorting, cataloging, and deciding the fate of these vast quantities of technology was no small feat. What was left over? The remnants of a war that no longer had any clear meaning. Thousands of engines, guidance systems, fuel tanks, and missile parts were scattered across factory floors, disassembled and discarded. Some parts were buried or left to rust in fields, forgotten as the world tried to turn away from the horrors they once represented. The sheer scale of the surplus was overwhelming, and the cost of storing or destroying it all was prohibitive. What was to be done with the remnants of a weapon that had once rained terror upon Europe? The answer lay not in a single decision, but in a series of fragmented, often contradictory choices. Some rocket parts were sold off to other countries in desperate need of technology. Some were repurposed for peaceful uses, reworked into research and development projects that would see some of these components find their way into civilian and military technologies. A rocket engine, after all, could be a useful tool for a new age of exploration, just not the one the Nazis had envisioned. Yet, as the Americans and Soviets focused on what they could extract from the pieces, other nations, particularly the United Kingdom and France, found themselves confronted with the question of what to do with the remaining wreckage of a broken war machine. In the early days after the war, it was the Soviets who were perhaps the most aggressive in their attempts to acquire the V-2's technology. At the heart of their interest was not simply the hope of gaining an edge in future warfare, but the reality that they needed to rapidly bolster their own rocket program to compete with the United States. When Soviet engineers managed to get their hands on captured V-2 components, they were able to reverse-engineer crucial systems, which would directly influence the development of Soviet missile technology. These efforts helped to propel the USSR into the rocket age, establishing the foundation for their future successes in space exploration and military missile systems. Meanwhile, the growing Cold War between East and West meant that the U.S. was faced with an uncomfortable dilemma: how to balance scientific curiosity with the reality of storing, managing, and dealing with the waste left over from the V-2 program. The sheer volume of parts and the complexity of the rockets meant that dismantling them was no easy task. By the mid-1940s, large portions of the leftover rockets were simply discarded, left to rust or disintegrate in the harsh German landscape. As vast numbers of these parts were destroyed, their original purpose as tools of war faded into a new context, a context that demanded new uses for old technology. The early 1950s marked a critical period of transition. By now, the immediate post-war scramble for technological advantage had given way to a more systematic approach. In some cases, rocket parts were sold off in pieces, with each fragment taking on a new life in the hands of different military contractors or research institutions. But many of the pieces, particularly those that could not be immediately reused, were melted down or scrapped in large quantities. The cost of storing them, of maintaining vast stockpiles of missile parts in an uncertain political landscape, outweighed any potential future benefit. The economic pressure mounted, especially as the Cold War competition demanded new focus. As military leaders turned their attention to the next phase of technological advancement, the rocket parts, once central to the Nazi war effort, were quietly dismantled, forgotten, or left behind. But this was not a simple process of destruction. Much of the V-2 technology lived on in ways that would become evident decades later. Some components found their way into the burgeoning world of space exploration. Others influenced the development of early jet propulsion systems, which would see the use of similar rocket technology in commercial aviation and military operations. It was not an immediate transformation, but the long-term impact of these parts was significant. They had survived the war and in some cases had been reimagined for entirely different purposes. As for the workers who had once been employed in the V-2 factories, their post-war experiences were equally complex. Many had been forced into labor under the Nazi regime, and the end of the war did not offer them an easy escape. They too were caught in the shifting political landscape, some sent to labor camps, others detained by the Allies for their role in the wartime economy. Their knowledge of rocket technology was both a resource and a burden in the post-war world, and they too had to reckon with the transformation of their labor from a tool of destruction to one of scientific progress, or, in some cases, to nothing at all. This was not just the fate of the V-2 rocket components, but the fate of an entire industry that had sprung from the ashes of war and the ambitions of a brutal regime. What happened to the remains of the V-2, once the pride of Nazi engineering, is a tale of technological rebirth, destruction, and obsolescence. But the story is far from over. There is more to uncover, more to understand about the ultimate fate of these pieces of history. The story of the V-2 rockets didn't end with the disbandment of Nazi Germany in May 1945. It had been a weapon of terror that had struck fear across Britain and the heart of Europe, but with the conclusion of active combat, the focus shifted from their use in warfare to dealing with their legacy. As the remnants of these powerful rockets sat scattered across Europe, abandoned in warehouses, on factory floors, or left to rust in the open air, the true scale of their impact had yet to be realized. It wasn't just the military leaders who saw the value in the technology. Scientists, engineers, and even former Nazi officers played a key role in determining the V-2's ultimate fate. But the decisions made in the years following the war weren't simply a matter of salvaging what was left. They were about forging new paths, repurposing old technology, and trying to put a broken world back together again. The Soviets, who had captured key facilities in Germany, were quick to realize the immense value in the V-2 technology. Soviet intelligence, spearheaded by military engineers like Sergei Korolev, made rapid efforts to dismantle, understand, and replicate the Nazi rocket program. But it wasn't just the V-2 that they were interested in, it was everything associated with it. The guidance systems, the engines, the fuel mixture, even the launching techniques were all meticulously studied. Over time, the Soviet Union was able to integrate key aspects of the V-2 into their own military and space programs, making significant leaps in both missile technology and rocket science. The Soviets' actions had far-reaching consequences. The Cold War was taking shape, and with it, the arms race. Soviet advances in rocketry, largely based on the V-2's core technology, would culminate in the development of the R-7 Semyorka, the world's first intercontinental ballistic missile, which, in turn, would pave the way for the USSR's early achievements in space. The 1957 launch of Sputnik, the first artificial satellite, was made possible in part by the work begun with the V-2. The Soviet space program's early successes in the 1950s and 1960s were intrinsically linked to the Nazi weaponry captured at the end of World War II, even though the narrative surrounding the V-2's post-war legacy is often overshadowed by the more famous achievements that came later. But for the United States, the situation was more complicated. While the Soviets had acted quickly and decisively, the Americans, at first, were more cautious in their approach. After all, they had inherited a world of wreckage, with Europe in ruins and the horrors of the war still fresh. It was the American Army's Ordnance Department, however, that had a vested interest in the V-2's components. The United States wasn't merely interested in studying the technology, it was determined to integrate it into its own arsenal, to build upon it, and to move forward. In 1946, under the guidance of the Army's German rocket program, led by Dr. Wernher von Braun, one of the Nazi rocket scientists who had helped develop the V-2, the Americans began a process of salvage and reverse engineering that would transform the post-war landscape of rocketry. Von Braun's expertise, along with the resources of the U.S. military, made it possible for the United States to conduct a detailed study of the V-2 rocket. The pieces of the weapon were shipped to the White Sands Proving Ground in New Mexico, where tests were conducted to assess the V-2's viability as a launching platform for American rockets. The first launch of a V-2 in America occurred in the fall of 1946, and while it wasn't a groundbreaking technological leap, it was a demonstration of the potential that the V-2 technology offered. The Americans, having secured a large number of German rocket scientists, saw a clear path forward. These scientists, many of whom had been integral to the development of the V-2, would become key players in the U.S. space program. The German scientists' transition from the Nazi rocket program to the American effort is now a subject of historical intrigue, with many of them playing a pivotal role in the birth of the American space age. However, the V-2's impact on American rocketry wasn't just about the direct technological transfer. It was about the lessons learned from the German engineering that had been so refined in secret. The U.S. military, while initially unsure of what to do with the surplus parts, soon realized the broader implications of the V-2's design. The lessons from the V-2 provided valuable insight into aerodynamics, propulsion, and missile guidance that would eventually be applied to the development of the Redstone missile, which, in turn, would launch America's first astronauts into space. This seamless transition from the V-2's technology to modern American rockets was not without its contradictions. What had been a weapon of destruction was now the basis of peaceful exploration, yet much of the post-war rocket development had roots in the very components salvaged from the V-2. Meanwhile, in the devastated landscape of Europe, the fate of the remaining V-2 parts became an economic and logistical problem. The sheer volume of leftover components, engines, fuel tanks, guidance systems, and a variety of other parts, was staggering. The Germans had been prolific in their attempts to produce as many rockets as possible before the war's end, but the demand for these weapons had ceased, and there was no longer any infrastructure to support their production. As a result, many parts were simply abandoned or left to rust in factories. In some cases, these parts were sold to other nations struggling to rebuild their own economies, while in others, they were buried or discarded altogether. For the citizens of Germany, the sight of these components, once the embodiment of Nazi power, rotting away in the open air was a stark reminder of the war's devastation. Yet, as time passed, the question remained, What could be done with this leftover technology? There was no immediate answer, and as the Cold War began to take shape, the remaining pieces of the V-2 program found their way into various government projects. Some of the leftover parts were melted down for scrap metal, repurposed for other industrial uses, or simply discarded. The economic pressures of the post-war era, combined with the growing realization that Europe had no interest in continuing to develop such technology, ensured that many of these parts disappeared from history, their fate sealed in the same way as so many other remnants of the war. By the late 1940s, as Europe slowly recovered from the devastation of war, the remnants of the V-2's legacy were becoming increasingly difficult to track. Some were repurposed for scientific research, others for military purposes. But the vast majority of parts, either left behind or destroyed, would never be seen again. Their technological significance, once central to the Nazi war effort, had been overshadowed by the need to rebuild and move forward. Even so, the impact of the V-2 was not entirely gone. The remnants of the rockets, the scientific knowledge derived from them, and the engineers who had been involved in their creation were all vital to the development of the post-war world, whether through their influence on space exploration, military missiles, or other technological advancements.